Great morning, afternoon, evening, my mini mathematicians. Thank you so much for being here with me today. Greatly appreciate it. We should be on page 20 and we're going to be going over 7.1c lesson. I'm on page 20. Are you on page 20? Awesome. Let's track the title together. 7.1c lesson, areas of irregular shapes and expressions. Remember, expressions are just mathematical phrases and there's no equal sign. Wonderful. And this is going to really connect to 7.1b with our irregular shapes we found there. Okay, please track along the directions while I read. Use your knowledge of area to find the area of the following shapes. Write an expression to show how you arrived at your answer. Let's take a look at shape A. Shape A is a special type of quadrilateral. That's right, it's a rectangle. So if I want to find the area of these shapes, an expression for the area for A is base times height. So let's see, the base 100 times 60, and 100 times 60 is 60 with 2 extra zeros, so 6,000. Which I know our final answer then is 6,000 square meters or meters squared. Awesome. Let's take a look over at 2a. Taking a look, I guess we should finish number 1. Suppose you had a 60 by 100 meter plot of ground on which you're going to plant a garden. In the corner of the plot, you want to build a 5 by 8 storage shed. How much area will be left for your garden? Does it matter which way the storage shed is oriented? So let's read that again, and as we're reading, let's make sure to try and draw a picture. Suppose you had a 60 by 100 meter plot of ground which you're going to plant a garden. Okay, so that's going to be a rectangle that is 60 by 100 meters. 60 meters by 100 meters. And this is a rectangle, so I'll show with my 90-degree angles. And it says there's a storage shed that takes up 5 by 8 in one of the corners. Pick a corner. Pick this corner. 5 by 8. Here's my shed. How much area will be left for your garden? So all of the remainder areas we left for our garden. Well, we're going to take the area of the entire plot of land, subtract the area the little shed takes up, and that will end up being how much land we can plant for our garden. So now we have to take our base times height of our whole plot and subtract the base times height of the shed. So we have 100 times 60, which we found as 6,000, minus the area of the shed, which is a 5 by 8, and 5 times 8 is 40, which means the area we have left is 5,960. And let's write that in a sentence. The area of the garden is 5,960 square meters, or meters squared. And the second part says, does it matter which way the storage shed is oriented? No. Let's think, how could I start this? The shed can be put in any corner. We're not changing the shape, and it doesn't matter if it's 5 feet tall and 8 feet wide, or 8 feet tall and 5 feet wide, because of the commutative property of multiplication. Awesome. So now we're going to take the same idea of this problem and we're going to put in some variables for some unknowns. So join me back up at 2a. So 2a, again, we're going to need an expression. It's a rectangle. So the area is base times height. But in this case, the base is x and the height is 60. which means our area is 60x, which in this case is 60x, and it's still square meters. Square meters or meters squared. A lot of times when I'm dealing with an extra variable, I don't really like using just the m squared because it can look kind of funny. So let's take a look at our word problem. You have a 60 by 200 meter plot of ground on which you're going to plant a garden. You don't want to plant the whole thing, just an area of 8,000 meters squared. If one side is 60 meters, how long will the other side, the 200 meter side, have to be to have an area of 8,000 meters squared? Well, let's draw a picture of this. The total area of the entire plot of land is 60 by 200 meters. So the total area is 200 times 60, which is going to be 12,000. Cool. So we know we're going to have 8,000 for our area. And we know this part is going to be the remainder of the area, so that would make up 4,000. These are both meters squared. So again, remember, this is still 60 meters this length, and we have to figure out how much is this length. Well, 60, because we know base times height, 60 times an unknown number, I'll call it x, is equal, we want to know how long does the other side have to be to have an area of 8,000. So we want to know about this section of the garden. We want to know about this section of the garden. So it's 60 by x, I'll call that x up here. Maybe it makes more sense to put it down here. And that's going to equal 8,000. So x is being multiplied by 60, so I'm going to divide both sides by 60 here. And you get x to be 133 2/3. So the land will be, and we're going to use dimensions here, 60 by 133 2/3. And that will be meters. Awesome. Let's look at part C. Please read along with part C. What percent of your 60 by 200 meter plot of ground or area will be planted? Well, we already said that we're going to be looking at planted to total to find this percent. So we have 8,000 meters squared planted, and we have 12,000 meters squared total of area. So when we reduce this, we end up with 2/3, which is 0.66 repeating. And that's the decimal, and we want to know the percent, so we move the decimal over twice to the right, and that would be 66.6%, or 66 2/3% of the land is planted. Cool. Great job. Let's keep going. Please turn the page. Awesome. Let's track the directions together. Use your knowledge of area to find the area of the following shapes. Write an expression to show how you arrived at your answer. So you need to show some work. So if I'm going to find the area of this shape, let's think about finding the area of the entire shape, the larger rectangle, and we're going to subtract. We're going to subtract off this smaller amount. We're going to subtract off that smaller amount. So we have this little skinnier rectangle. Okay, let's fill in some numbers so we can find the areas. Our big rectangle is a 7 by 5. And our little rectangle, well, this says it's a 2, and this is a 4, so 2 by 4. So base times height is the area of a rectangle, so we have 7 times 5 minus 2 times 4. 7 times 5 is, that's right, 35. 2 times 4 is 8, and what's 8 less than 35? 27. So our answer is 27 square yards. Cool. Let's take a look at number 4. Number 4 looks like a very similar shape, so I'm going to use the same idea. I'm going to take this whole rectangle and I'm going to subtract off the little rectangle to just have the area of the figure. So now this shape is an x by 5, and our little rectangle is a 4 by 2. So base times height, 5x minus, and 4 times 2 is 8. And that's all I can do here. That's as far as you can simplify, because 5x and 8 are not like terms. I have to stop there. So I'll say that my answer is the quantity of 5x minus 8 square yards. And that's your final answer. That's as far as you can go. Nice. Let's take a look at number 5. When I'm looking at number 5, I also, again, see a large rectangle, and I'm going to subtract out this smaller rectangle. Except this time, I'm not given this width of my rectangle. So again, I'm going to take the big rectangle, and this is a 60 by 100. And I'm going to subtract off this small rectangle. And this is where it gets to be really fun, because we get to use what we know and make a puzzle. So we know that this length is 45. And taking a look at this height here, well, we know this whole entire side length is the same as the opposite side length. So this whole length is congruent over here, which means that it's, you're right, 60. And if from here to here is 12, and from here to here is 34, we just need to find this amount from here to there. Oh, I have an idea. This remaining amount is 60 minus 12 and minus 34, or 12 plus 34 minus take away from 60. So let's think about that. 12 and 34 get me how many? Get me 46. And 46 less than 60, well, that's 14. So this has a base of 14, or a width of 14. So we have 60 times 100, base times height. And then we're going to subtract the area of our smaller rectangle, which is a 45 times 14. Excellent. Grabbing your calculators, well, that's going to be 6,000. Take away 630. And when you subtract that from each other, you get 5,370. Let's write that as the answer now. 5,370 square meters, or meters squared, because this is area, 2 dimensions. Excellent. Let's take a look at number 6. Again, it's going to be set up very similar to number 5, except this time we're going to be missing a value. So let's take a look. We're going to have the area of the large rectangle, which is a 60 by 100, and we're going to subtract the area of the small rectangle. Go ahead and work with your group. Pause the video for 2 minutes and finish up number 6. Awesome. Let's see how we did. So we found the area of the big rectangle to be 6,000, the small to be 14x. So we have the expression of 6,000 minus 14x meters squared. And notice I do put that expression inside parentheses. Awesome. Let's look at page 22. Write an expression to represent the indicated value of each of the following irregular shapes. We need to find the area and the perimeter here. So I'm going to pause the video. We're actually going to start a new video. and I'm going to give you 3 minutes to start this one up. So go ahead, work for 3 minutes, and then we'll start.